velocity is nothing but is equal to speed, and velocity is nothing but the distance traveled, which means to say the displacement taken place by an object in certain interval of time is called as velocity. So whenever the projectile motion takes place, we have a range, height, that is the maximum height, as well as a parabolic path, that is called as a trajectory. The force of an object which is moving around a circle is acting towards the center, so for which we call it as centripetal force. Hello everyone, I am Rinda, Faculty of Physics from Vidhyaashram School of Excellence, Mysuru, welcoming you all to another session, that is from chapter Motion in a Plane, class 11. So let us just deal with few of the concepts from the chapter Motion in a Plane. Whenever a plane concept comes, what is the first thought comes to your mind? That is your x-axis, y-axis, correct? So there are 2D axis, that means to say two-dimensional axis. So here we study about the two-dimensional axis, the vectors, the scalars, whichever you have studied in the previous session, and now we are getting into the motion in a plane chapter from the second session, and that is we deal with relative velocity. What is meant by a relative velocity? Usually, relative velocity. You know what is velocity? Velocity means distance traveled in certain interval of time. Correct? Velocity is nothing but is equal to speed, and velocity is nothing but the distance traveled, which means to say the displacement taken place by an object in certain interval of time is called as velocity. So why do we want to relate it? Why do we call it as relative velocity? We have to relate the concept there. That means to say, here you can see two cars. Relate. When do you relate one object with the other object? One object with the other object. So there lies the answer. There are two objects. When there are more than two or more than two, then we will just handle this relative velocity. We relate it with each other. So we relate the velocity of one object with respect to another object. So you can see here the two cars are moving in a straight line. So call this as car A and call this as car B. You have to relate this. So in order to relate this, you go with the relative velocity of two objects are VA minus VB. V means velocity of the A object with the velocity of B object, you relate it. Suppose if both are in the same direction. Suppose if both are in opposite direction, what are you supposed to do? Opposite direction, one direction is towards, one direction is away. So we have a negative here. So relative velocity is equal to velocity of the car A or a vehicle A minus of negative vector velocity of car B. So you have minus because it's an opposite direction. So minus into minus becomes plus. So VA plus VB is what we have the equation for relative velocity. So I hope you're clear with what is relative velocity. Relative velocity is the velocity of one object with respect to another object is the definition for it, and this lies as an equation. So coming to the next concept, it is projectile motion. So what is meant by a projectile motion? Projectile, which means first of all a common and an easy thought which comes to, or easy example which comes to our mind will be a cricket ball. Suppose if a ball is, that is in cricket match, when a ball is thrown from one place to another place, final is here where it touches the bat and initial is in this manner. Correct? And this is a sixer. Correct? So now here we have a motion, and this type of motion is called as projectile motion, which gives you a parabolic path. This is the initial point and this is a final point. From initial to final point, the distance is present over here, that is a horizontal distance, and horizontal distance is named as range. And it has n number of angles which is forming over here. One is a horizontal angle and another one is a vertical angle. This lies with respect to resolution of a vectors. That is, a vector, the vector which is along this direction has resolved into two components. One is a horizontal component, one is a vertical component. Horizontal component lies to be initial velocity it is, so u cos theta. And your vertical component lies to be u sin theta. And this is the velocity vector u. I hope you're clear with the initial velocity. Same thing goes up with the maximum height too. We have u cos theta. Here we don't carry any of the vertical concept. Next we have maximum height, which lies here. Again we have a vector which gives you a components, horizontal and vertical components. So you have u sin theta here and u cos theta here. Everything from initial till it reaches final, everything is u. And velocity v at the final, that is the final velocity v, is said to be 0 as it touches the ground after it undergoes this parabolic path. So this type of a motion is called as a projectile motion. So coming to this, you can see different examples with respect to projectile motion. So here we have projectile is nothing but when an object is thrown into space, as you can see there in the diagrams, when an object is just thrown into the space, what happens? Its initial velocity, it makes an angle, it makes a certain angle with the horizontal. That is the projection. Okay, so that is called as your projectile motion. Okay, it makes a angle with the horizontal component. So that is the projectile motion. So I hope you're clear with the what is meant by projectile motion. So whenever the projectile motion takes place, we have a range, height, that is a maximum height, as well as a parabolic path, that is called as a trajectory. So you have the motion. See here, fountain also makes a projectile motion, as you can see over here. Okay, similar way, when a projectile motion undergoes a parabolic path, we have a maximum height here and we have a trajectory. Trajectory is nothing but a parabola, the path taken from initial to final. Okay, and we have different set of angles and the range from initial to final. It is the distance is called as a range. So I hope you're clear with projectile motion. So we need to calculate what will be its maximum height. What will be the time taken by an object to fall from initial to final distance. And next will be your displacement, that is the range. Whatever displacement you can see here, that range we are supposed to calculate. So we need to calculate maximum height, we need to calculate range as well as time taken by an object to follow that parabola or a trajectory. So we shall derive those things. So I hope you know the equation of motion. V is equal to u plus at, v square is equal to u square plus 2as, and s is equal to ut plus half at square, 3 equation of motion. So going on with it, we have projectile motion. Let us calculate height, that is h max. What are we supposed to do? We know that v square is equal to u square plus 2as. V square is final velocity, u square is initial velocity, plus of 2 is a number, that is a magnitude, a is the acceleration, and acceleration due to gravity we are supposed to check. Since the ball is falling down, it will be minus of g. Okay, s is nothing but the displacement taken, so which we consider it as a h max, it's a height. Okay, so now we have v square is said to be final velocity, it is 0. U square is nothing but, since it's a component which is moving, that is we have y-axis, x-axis, and there is a parabolic path, and we have the resolved components as u cos theta, u sin theta. Again we have a resolved component u cos theta here, and here also we have u cos theta, u sin theta, and this distance from the x-axis to the y-axis, it is h max, and the range starts from here to here. This is called as range. So we consider the horizontal component over here. So we have u cos theta, u sine theta. Here we consider u sine theta component, that is this, because it is moving under vertical direction. So we have u square sine square theta plus 2 of acceleration due to gravity is downwards. So it is negative of g. Second, rewrite this as minus g of s. S is the displacement of the object. H max is what I'm considering because I'm calculating the H max itself. So what happens to this? You have to calculate H max. Take your u square sine square theta minus is equal to minus 2g H max. Minus and minus goes out. So how do you calculate H max now? To calculate H max, you have u square sine square theta divided by 2g. So this is one of the important formula for you to calculate the numerical, or in order to undergo or solve the problem. Okay, so this formula is used to calculate the H max, that is maximum height of the projectile motion. Okay, so this is all about your calculation, wherein you have to remember this equation of motion, third equation of motion. Okay, so next is we have to calculate time. Calculate time interval between initial and final velocities. Okay, to calculate, let us divide this into total time taken is equal to time of ascent plus time of descent. Time of ascending and time of descending in the parabolic path. Time of ascending, time of descending. 2 times we have to add it. So how exactly it goes? We have a equation v is equal to u plus at. V, since velocity, as you all know, it is 0, we consider it as 0. U is u sine theta plus a is acceleration due to gravity, and we have time of ascent. So how do you calculate a time of ascent? Minus u sine theta is equal to minus g of t. Minus and minus goes. U sine theta divided by g will be your time of ascent. Okay, let us call this as equation 1. Similarly, you have the same equation, time of descent. U sine theta divided by g is equal to this also, time of descent. For a change, we can write ta, 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 ta. Here also the same thing. This is TA and here we go with TD. Okay. So this is your equation 2. We have equation 1 as well as equation 2. Apply this in this equation. Let me name this as equation star. Applying it on that, we have T is equal to time of ascent and time of descent u sine theta by g plus u sine theta by g. Together, on calculating, we have T is equal to 2u sine theta by g. So this is one set of equation what we have. So now this is how you calculate the time for a projectile motion. Next we are left with range. So we need to calculate range. How do you calculate a range? In order to calculate the range of a projectile, what are we supposed to do now? Range is nothing but the distance which is from initial position to final position. Again, your x-axis, your y-axis, projectile motion. Range is this one what we calculate. So this is nothing but the displacement which is taken from one point to another point by a particle. So that displacement, as you all know, in general we know that what is displacement formula? We know velocity is equal to displacement by time taken. So time goes with velocity. So displacement is equal to velocity into time. So displacement or distance is nothing but the range. Range is equal to velocity into time. What is velocity? We have u cos theta is the velocity which is moving in a horizontal direction. We consider a horizontal speed here into the time taken. This is a capital letter T which we have already derived in the previous slide. That is this part. T is equal to 2u sine theta divided by g. So add it here, 2u sine theta by g. So what do we carry now? R equal to, we have u into u square, and we have cos theta into 2 sine theta. 2 sine theta into cos theta is nothing but sine 2 theta according to the formula. and you have divided by g. So u square sine 2 theta divided by g is the range of a projectile. So this is how you calculate. So remembering height, maximum height, remembering time as well as remembering range is very much important because it's very useful in solving the numericals. Okay. So next we are going on to uniform circular motion. So what is meant by a uniform circular motion? Here we have center, circumference of a circle, and the acceleration is acting towards the center, which is because of which we name it as centripetal acceleration. The force of an object which is moving around a circle is acting towards the center, so for which we call it as centripetal force. Any object or any acceleration or any force which is acting towards the center is known as centripetal acceleration and centripetal force. So here this red line symbolizes the velocity, how velocity is moving, and blue line gives you the acceleration of a particle which is moving in this circumference, and this would hold as a direction of motion of an object. So whenever an object moves in a circular path in a uniform angular velocity, then it can be termed as uniform circular motion. Okay, now let us check what is a centripetal acceleration, and let us derive an expression with respect to linear velocity as well as angular velocity. So we know this diagram holds good for your circular motion. Towards the center, acceleration is acting, and acceleration is always perpendicular to the velocity. Okay, it's acting along the line of the circumference of the object over here, and force is acting towards the center, so it obeys centripetal acceleration. Force is towards the center, therefore it obeys centripetal force. Okay, so now same diagram, just few changes. So here is a circle and here is a center. Okay, we have a radius over here, two radius we give. Suppose consider this as a point O or a origin, and this is a point A, this is a point B. The velocity vector of point A is given in terms of this manner. You can see there a red line. Okay, so this velocity can be given as just V. And another velocity which is acting with respect to this is also V. And this velocity is resolved into two components. Now, to show the resolution for this velocity, we have one as horizontal component and another one is vertical component here, which is termed as V sin theta, and this is termed as V cos theta. So we have V cos theta, V sin theta velocities now. Yes. Consider the change in velocity at this point A. Okay, from this point A to point B, a particle has moved from this point to this point and it has resided here, point A to point B. So there is a change in velocity from initial to final. So it is V and V cos theta. So that change in velocity you can give it as final velocity minus initial velocity. So change in velocity at point A is given as V cos theta minus V. So suppose if the angle which is made is very, very small, cos theta becomes approximately equal to 1 if it is small. If the angle made by the object is very small, then theta turns out to be 1. Cos theta turns out to be 1. Okay. So now, we have V minus V. This is the velocity. So this is the change in velocity. So we change in velocity equal to, we add equal to here. V, positive V cancels with negative V. So we have change in velocity to be 0. Delta V or change in velocity is said to be 0. Okay. So now the condition is in 0th condition. So this will hold as a final point for the next equation to be derived. Again, change in velocity at point B. Change in velocity at point B. What do we have? which is equal to v sine theta, that is, this is final now. Difference of these two velocities is the initial. So this holds as initial now. Okay, and this is final. So v sine theta minus 0. 0, the value whichever we have got, that would be staying as initial concept. So now, since sine theta, if sine theta angle is very small, again apply the same condition. What happens? It becomes approximately equal to theta. In sine theta, if the angle is very small, it becomes theta. Okay, so we have v sine theta minus 0. Yes, so sine theta turns out to be theta, so we have v theta minus 0. So change in velocity over here is nothing but v theta. Yes, we have got two set of equation. Having this, that is v theta, change is happening in the velocity at point B. We just consider it and we just further analyze it. Okay, so this is the change in velocity. Yes, so therefore, how do you define a centripetal acceleration? Centripetal acceleration is defined as rate of change of velocity with respect to time. Rate of change of velocity is this v theta. So we go with v theta final minus 0. So we remain with v theta divided by we have t. Yes. So what happens to acceleration becomes v theta by t, and we already know that theta by t is nothing but since omega, angular velocity is displacement by time taken, angle by time, omega is equal to theta by t. So v into omega, you can write A is equal to v into omega concept. This is the equation for centripetal acceleration. So now we need to apply for two cases. One is for your linear velocity. And another one is for your angular velocity, whose formula is very, very important with respect to your centripetal acceleration. One is linear velocity, one is angular velocity. You know the relation between linear velocity and angular velocity. That is very simple. We have v is equal to r omega. Correct. In case of linear velocity, we just consider omega is equal to v by r. What is omega? With the help of this, we derive omega. We have A by V, which is equal to V by R. V goes with V. So A is equal to V square by R. What is A? That is centripetal acceleration. It's not just acceleration. So we just add subscript to it as C. So AC, centripetal acceleration, is equal to V square by R. That holds good for linear velocity. Next is angular velocity. To hold good for angular velocity, we just have an equation V is equal to R omega, write directly. So what is V? V is A by omega. A by omega, which is equal to R omega. Okay, omega goes with omega, so we have A is equal to R omega square. So this holds good for centripetal acceleration with respect to angular velocity. So this is the very important derivation where you have to know how to derive for linear velocity and angular velocity. That is, with respect to, we derive for centripetal acceleration with respect to linear and angular velocities. Okay, so here in this session we have studied about relative velocities, projectile motion, as well as circular motion, that is uniform circular motion, and its derivations. So let us all meet in our next upcoming session. Until then, have a good day. Thank you.